Good evening. I think you can see the slides. So today we will discuss the basic concepts in the relations. So first of all, uh, relation. Before going to relation, first we should know what is the Cartesian product of two sets A and B. So that is a basic thing that maybe you studied in the lower standard, Cartesian product of A comma B. So now, okay. So let A and B be two non-empty sets. A relation R from A to the set B is a subset of A cross B. So a relation is a subset of A cross B. So A and B are two non-empty sets. If R is a subset of A cross B and A comma B is an element of R, so then what is the meaning of A comma B belongs to R means we say that A is related to B, A is related to B by the relation R. So that is the meaning of this notation. A comma B belongs to R. And also we can write A is related to B. If A is not related to B now, then you can write what? There are two ways you can write. One is, okay, I'll write, I need so you can write if A is not related to B means you can write A R and then you can cross this R like this and then B. Or otherwise you can write A comma B does not belongs to R. Does not belongs to means I will write the symbol. Okay, you can write because just now we opened the board. Maybe I will using the board. I will write this notation and then I will go to the next concept. So okay, maybe I'll go to the next concept and then I'll come back again. So here you can see here. Let A is what? The set 1, 2, 3. Okay, yes. So A is related to B means I can write either you can write A comma B in R. I think here you can see here. Okay, the previous slide. Okay, or you can write A is related to B. Suppose A is not related to B means A comma B is not in R. Not in R. Or you can write A not related to B. Okay. So now I'll go to the slides. Okay. Now the next examples for relations. Suppose A is a set 1, 2, 3, B is a set A comma B, then the subset R equal to 1 comma A, 1 comma B, 2 comma A, 3 comma A is a relation from A to B because this is what subset of what A cross B. So is a now R is a relation from A to B. It is defined by, you can write like this also. 1 is related to A and then what? 1 is related to B, 2 is related to A, 3 is related to B. Okay, second example, at A is equal to 1, 2, 3, 4, we define a relation on A by A is related to B if and only if A is less than B. So then the relation is, this is a set, what is the relation? A is less than B. So that's why A is less than B. So 1 is less than 2, 1 is less than 3, 1 is less than 4. Similarly, 2 is less than 3, 2 is less than 4, 3 is less than 4. So this is a relation R. Okay, wow. So now next, A equal to set of all positive integers. That means Z plus. Z plus means a set of all positive integers. We define the relation R. Relation here, the relation is what? Less than, that is A less than B. Here the relation is divisor of, is a divisor of in R. Okay, so how we define? A is related to B if and only if what? A divides B. Here how they define? A is related to B if and only if what? A is less than B. Here A is related to B if and only if A divides B. Okay, so A divides B. Now you can see here 4 divides what? 12. Okay, but 8 does not divides what? 18. So exactly. So 4 divides exactly 12, but 8 does not divides exactly 18. So next, another example for relation. Let A be the set of all real numbers. So A is a set of all real numbers. We define the relation X is related to Y if and only if X and Y satisfies this inequality. That is, this is actually what? If it is equal to 1 means ellipse. So x square by a square plus y square by b square less than or equal to 1. So then the set R, okay, R you can say it's a relation R, okay, because R is a relation. The R is the the relation R consists of all points on and the interior of the ellipse. Because why it is on? Because less than or equal to. So that's why on the ellipse, strictly less than also. That's why interior of the ellipse. So R contains this, the relation R contains this is the relation. Okay, R equal to set of all x comma y. Okay, set of all this x comma y. The x comma y is here interior point, such that x square by this x and y satisfies this inequality. X square by 4 such that x square by 4 plus y square by 4 less than or equal to 1. So it may be this point lies on the boundary also. Okay, so that's why it is mentioned, which contains, this relation R contains all the points on and interior of the ellipse. Okay, next. So next, this is a basic questions. Suppose A and B are what? Two sets. So A has m elements, B has n elements. So now the question is, first question is, how many elements has A cross B has? So naturally, mn elements. Okay. So A has m elements, B has n elements, means A cross B has mn elements. Okay. So before going to the next question, so we know that a set contains n elements. Okay. 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 So there are two questions. First, I answer for the first question already. So before going to the next question, we should already know this idea. A set a set contains n elements. Okay, has how many subsets? So 2 power n subsets. Okay. So that is already you know that. So now the question is, how many different relations are there from A to B? So how many different relations are from A to B means, now again, how many subsets it has? Okay, as the number of subsets of A cross B is what? The number of elements, first of all, number of elements is what? Number of elements in A cross B is what? We know that mn. So and hence it has the total number of subsets are what? In A cross B, 2 power mn. So there are 2 power mn different relations from A to B. So that is the answer. So for this, you should know this idea. Okay, as a set contains n element has 2 power n subsets, and we know that every subset of A cross B is what? It's a relation. So totally how many subsets we have? 2 power number of elements in the set. What is the number of elements in the set A cross B? Mn. So totally 2 power mn subsets. In you have 2 power mn subsets. You have what? In A cross B. So those many, that means what? 2 power mn different relations from where? From A to B we have. So if you have any doubts, you can ask to me in this question, or otherwise we go to the next problem. Okay. So next, domain and range of a relation. Let R be a relation from A to B. Okay. Let capital R be a subset of A cross B. The domain D of the relation R let R be the relation from A to B. That is, R is what? A subset of, a relation is a subset of A cross B. The domain D of the relation R is the set of all first elements of the ordered pairs which belong to R. So that means the domain, okay, capital D is equal to set of all A such that A is in what? In capital A. And A comma B belongs to what? R for some B in capital B. So the domain contains the first element of the ordered pair. Similarly, the range E of the relation is the set of all second elements of the ordered pairs. For example, if you have A comma B in R, the range contains what? The second element B. That B belongs to where? Capital B. Okay, comma A comma B in R for some A in capital E. So clearly the domain of a relation from A to B is what? Is a subset of what? A, and its range is a subset of B. Okay, now you can see here example for domain and range. Let A equal to 1, 2, 3, 4 and B equal to RST. Okay, and R equal to the relation 1 R, 1 comma R, 2 comma S, 3 comma R. The domain of R is what? 1, 2, 3. The range of R is what? R and S. Okay, similarly, suppose let R be a relation from A to B. This is A, this is B, which is defined by the expression X divides R. Write, first question, write R as a set of ordered pairs. Second question, find its range and domain. So here X divides Y means, so 2 comma 6, okay, or 2 comma 6, 2 comma 6, okay, 2 comma 10, okay, next 3 comma 3, and then 3 comma 6, and then 5 comma 10. So X divides Y. Now the domain of R is the first element, 2, 3, 5. The range of R is the second element, 6, 10, 3. Next, representation of a relation. So you can represent the relation using matrices. Suppose A equal to A1, A2, AM and B equal to B1, B2, Bn are finite sets containing M and N elements respectively. R is a relation from A to B. we can represent the relation R by a M cross N matrix. So MR means a matrix representing the relation R is equal to Mij, which is defined as follows. Mij is equal to 1 if Ai and Bj are related. It is equal to 1 if Ai and Bj are not related. So for example, you can see here A equal to 1, A1, A2, A3, B equal to B1, B2, B3, B4, and R is the relation given by, so A1, B1, A1, B4, okay, I think they gave this relation. Now MR. MR means matrix representing this relation. So this side you should write the elements in A. Okay, A1, okay, A1, A2, A3. This side you should write what? The elements in what? B. B1, B2, B3, B4. So A1, B1 is here. That's why 1. A1, B2 is not there, 0. A1, B3 is not here, 0. A1, B4 is there. So that's why 1. Similarly, you should fill up the remaining elements. Similarly, next what? The A2, B1. A2, B1 is 0. A2, B2. A2, B2 is okay. That's why 1. Similarly, you can fill up the remaining. Okay. Next idea is digraph or directed graph of a relation. So this is the theory part. So using this theory, we are going to solve the problem, simple problems. I will explain what is the theory in the using the problem. Okay, let A equal to ABCD set, and R is a relation on A, has the matrix MR. They gave the relation also. So construct that digraph. Digraph means directed graph of R, and list the in degree and out degree of all vertices. Clearly, okay, you can write this side also ABCD, this side is also ABCD. So here 1 means A comma A, this position. This is what? A comma B. This is A comma D. Similarly, this is what? B comma, B comma C. B comma C is here. Similarly, you can write the relation. Now, for each vertex, we need to draw the digraph also. The digraph, next slide, you can see. So, how many elements in the set A, B, C, D? You can see here A. Okay, this is what? B. This is C. This is D. Now you can A to A. A to A means you can put a self loop like this. This is called self loop. A to A, and then A to B means A to B. So directed. So here have direction A to B. Next A to D. A to D means A to D like this direction. Next B to C. B to C. B to C here. Okay, direction is towards C. Next C to C means self loop. Okay, and then C to D. C to D. Okay, and then D to A. D to A is this. Okay, now we should write digraph of a relation is over. Next, we should write what is the in degree and out degree of each of the vertices. First, I am writing A, B, C, D in degrees. In degree means how many of them coming towards A. So that is called in degree. So this is coming towards A, 1. So this self loop is count for both in degree as well as out degree. So in degree, this is I will count self loop is always for because it is going out and also coming inside. So that's why you should, this is I will count for both in degree as well as out degree. For A, now in degree is what? 1. This is 1. 1 plus 1, 2. Next B in degree only 1. C in degree 1 and this self loop 2. For D in degree only 1 and from here 1. 1 plus 1, 2. For out degree for A. Out degree for A means here out degree This is out degree for A, 1. This is also out degree for A. Okay, out degree means it is going from A. Okay, it is going from A. Okay, so 2 and self loop 1 plus 3. And out degree for B, out degree is only 1. Okay, it is leaving from B. Okay, one. Out degree for C is what? So I am, which one leaves from C? This one. This one also self loop 1 plus 1 2. Out degree for D is, this one is only 1. So this way you can write in degrees and out degrees. So these are some of the exercise. So A equal to 1, 2, 3, 4 and B equal to X, Y, Z. Consider the following relation from A to B. So R is a relation. Determine the matrix. Okay. So first here you should write what? 1, 2, 3, 4. Here you should write what? X, Y, Z. So 1 comma Y, 1 comma 1. This is 1 comma X. So 0. This is what? 1 comma Y. This is 1 comma Z. Similarly, you should write the remaining elements. Okay, here a set is given and the corresponding matrix for the relation is given. You should write the in ordered pairs. Usually the ordered pairs is given, we are writing what? The matrices. This is the opposite way. So this is here should write what? 1, 2, 3, 4, 1, 2, 3, 4. This element is 1 comma 1. So here 1 means what? 1 comma 1. 1 comma 2 position is what? 0. So 1 comma 3 is here, and then this is 2, this is 3. So 2 comma 3 is here. This is 3, this is 1 here. So 3 comma 1. Similarly, 4 1 4 2 4 4 4 1 4 2 4 4. So next problem here, find the relation determined by the following digraph. So directed graph is given. He should write the relation from this, and also find the in degree and out degree of the, you know how to find the in degree and out degree. The relation you should write. Okay, so here the relation is, actually first you should write what is the set 1 2 3 4 5. 1 2 3 4 5. The relation they are writing 1 comma 1 1 to 2. Okay, next 2 to 2. 1 to 2, 2 to 2. Next 2 to 3, 3 to 4. 3 to 4, 2 to 3, 3 to 4, and then 4 to 4, and then 5 to 4, 4 to 4, 5 to 4, and then one more 5 to 1. And then you need to find what? In degree for each of the vertices, and also out degree for each of the vertices. So this one already I explained in the previous problem. You can check it here also. So this is again a similar problem, I think so. Find the the digraph is given. You need to find what? The relation. So I leave this problem to you. You can check it whether the relations are correct. First I will tell at least one example. First you should write A. What is A? 1 2 3 4 5. 1 to 2 is here, and then 2 to 2. 1 to 2, 2 to 2. 1 to 3 is here, 1 to 4 is here. Similarly, you can write remaining elements. So maybe this is the last problem and relation. So A is a set 1, 2, 3, 4 and R is a relation. Draw the digraph. Totally 4 elements, 1, 2, 3, 4. 1 comma 1 means self loop. 1 to 3 means 1 to 3. 2 to 3, this is 2 to 3. 2 to 3, and then 3 to 2, this is 3 to 2, 3 to 3 is a self loop, and then 4 to 3. Next concept, operations on relations. So operations on relations, like we are going to discuss intersection, union, and complement. So first we will discuss union. Okay. So here R and S are relations from A to B. So R union S is equal to set of all A comma B is belongs to A cross B such that A comma B either in what? R or A comma B in S. Suppose A comma B is in either in R or A comma B in S, then A comma B in what? In R union S. As usual, union we know, okay, the meaning of union of two sets. Similarly, this is union of two relations. R intersection B again is equal to set of all A comma B in A cross B, such that A comma B should be in both R and what? In S. Then only it is in what? R intersection S. Okay, next complement of relation. Here they wrote R square. Usually for complement, we will write, we don't use R square. We will either write R complement like this, or we can write R complement, R power C like this. I think usually they will use this notation, I think. Okay, now don't use R square here, R complement. So what do you mean by R complement? So it contains elements in A cross B such that A comma B is not in R. Okay, so in our complement, those elements which is not in R, it is in the complement. So okay, I think you understand what do you mean by complement. Okay. Next, inverse of a relation. So every relation R from a set A into B has inverse relation R from B to A, which is defined by R inverse is equal to set of all B comma A such that, this line means such that B comma A in is an element of what? R. So A comma B in R na, B comma A is in what? R inverse. So next, we know that R is a relation from A to B is a subset of what? The Cartesian product A cross B. Okay. Suppose the inverse relation R inverse is a subset of the Cartesian product what? B cross C. And the second note, R inverse whole inverse is equal to R. Okay. Next, let A equal to ABC and B equal to 1 comma 2. R is a relation, this relation is a relation from A to B. The inverse of R, okay, inverse of R is what? 1 comma A, 2 comma A, 1 comma C. Similarly, the second column, you can see the inverse. This is this is a set. This is the relation. Inverse of R is R inverse. You can write this the same procedure. The next concept, composition of relation. Okay. So I'll through example we will discuss composition of relation. So A equal to 1, 2, 3. B equal to 2, 3, 6, 8, 12. C equal to 13, 17, 22. R is a relation, it is given like this. S is a relation. We should find S composition R. S composition R means first you should apply R and then you should apply what? S. So now first I will take an element 1 comma 2 in R. Next, so here ending with the 2 means I should take an ordered pair starting with the 2 in S. So there are two pairs, okay, starting with the 2. So 2 comma 13. Okay, so now 1 comma 2 is an R, 2 comma 13 in S na, 1 comma 13 in where? S composition R. So in the S composition R, first I am applying what? This R. And then I am applying what? This S. Okay, similarly, you can do next that 1 comma 2 I will take is an R, and then 2 comma 17 in S. So 1 comma 17 in S composition R. Similarly, you should write the remaining elements. So this is the, I'll tell one more, 1 comma 3 in R. So it's ending with the 3 means starting with the 3 is what? There are two elements. So 3 comma 13 in S. So 1 comma 13 in what? S composition R. Next 1 comma 3 in R. 3 comma 22 in S na, 1 comma 22 in where? S composition R. So first you should apply R and then you should apply what? S. So these are the distinct element. in S composition R. Okay. So using diagram also you can easily find out. So first you should write the set A. What is A? 1, 2, 3. 1, 2, 3. The B is what? 2, 3, 6, 8, 12. And then C is 13, 17, 22. So R is a relation. Okay, first R in the relation 1, 2. 1, you should put a arrow. 1, 2, 1, 3, 1, 2, 1, 3. Okay, was. And similarly what? 1, 3, 1, 2, 1, 3. And then 1, 12. Yeah, 1, 12. Similarly, should put arrow. Similarly, from B. Sorry, B means 2 to 13. Next to 2 to, sorry, yeah, B. This is B. This is C. Okay. So now, first apply, there are two relations R. Okay. So 1 to 2, 1 to 3, 1 to 12. I think we saw that. And then 2 to what? 2 to 3, 2 to 6, 2 to 3, 2 to 6, and then uh, 2 to 8, 2 to 12, 2 to 8, and then 2 to 12. And then from 3, I don't have any element from 3. Okay. Next, S. 2 to 13, 2 to 13, 2 to 17. Similarly, you should do all combinations in S also. Now, first apply R 1 to 2 and then what? 2 to 13. That means 1 comma 13 in R composition, sorry, S composition R. S composition R. So in S composition R, first you should apply what? R. R, and then you are applying what? S. Okay, maybe we will discuss a little bit more. Okay, I will take this slide. Okay, so already we discussed matrix representation of a relation. So if R is a relation from A to B, so you know Mi, the matrix Mr equal to Mij, the elements Mij is equal to 1 if A and Bj are what? Related. It is 0 if A and Bj are what? Not related. Okay. So here I think these are some of the examples. They gave the relation how to find the matrices. Similarly, if they gave the relation, okay, matrices, how to find the relation. So these things already we discussed. Next, R and S are relations on a set A, represented by Mr and Ms. And then what is the R union S? Already R union S we discussed. Here they mentioned it is a join. The R union S is a join of what? Mr and Ms. So M matrix representing the relation R union S. Okay, matrix representing the relation R union S is equal to Mr. This is a matrix representing R. Join Ms. Ms means matrix representing the relation S. Okay. So here in Mr join Ms has 1. Either Mr has 1 or Ms has 1. It has 0 if both of them, both the places, if we have what? 0, then only it is what? 0. Okay. Suppose 1, 1 nalo 1 da, 1, 0 is also 1, 1, 0, 1 nalo 1. Next, the matrix representing R intersection S is the meet of Mr and Ms. So the matrix representing intersection of R and S is equal to Mr meet Ms. So here this is actually you can see here it's obtained by putting 1 in the position where both Mr and Ms has 1. Okay, the elements here also 1, here also 1. Then only the corresponding position is what? 1 here. Suppose here 1 0 now 0 now. 0 ஒன்னாலும் 0 தான், 0 0னாலும் 0 தான். Okay, next, you know that join and meet are denoted by this symbol. So now you can see the example. For example, R and S are relations on a set A represented by the matrices MR and MS. We need to find MR union S. That is a matrix representing R and R union S is MR join MS. So MR join MS means just correspondingly you can add. So 1 join 1. So you should put what? 1. Next 0 0 means 0. 1 1 join 1 is 1. Next 1, next 1 1. Okay, just addition, look like the addition, 1 plus 0 like this 1. So don't put 1 plus 1 is 2. Okay, 1. Okay, 1 join 1 is 1 only. Okay, next 1 join 0 is what? 1. 0 join 1 is 1. 0 join 0 is 0. Next, matrix representing an intersection of two relation MR intersection S is equal to MR meet MS. So that means here 1 and 1. 1 and 1 is what? 1. 0 and 0 is 0. 1 and 1 is what? 1. Next 0 and 1 nalo 0 da. 1 and 0 is what? 0. 1 and 0 is what? 0. Similarly, last row. Okay, 1 0, so 0. 0 1 0 0 0 is 0. Okay. Next idea is how to find the inverse of the relation. You know how to find the inverse of the relation easily. Actually, suppose R is a relation from A to B represented by the matrix of the relation MR. Then the matrix representing R inverse, that is the inverse of R, is MR transpose. That is the transpose of the matrix MR. For example, if we have A equal to 2 4 6 8 and B equal to 3 5 6, and if the relation R is defined by like this, then the corresponding matrix here you should write what? 2, this 2 4 6 8, here 2 4 6 8, this side 3 5 7. So 2 comma 3 means here 1. This element is what? 2 comma 5. Yes, 2 comma 5 is here. 2 comma 7 is not here, that's why 0. Next, this position is 4. 4 comma 3 is not here, 0. 4 comma 5 irka? Yes, 1. Next, 4 comma 7, yes, 1. Similarly, remaining 2 rows you can fill up. So R inverse you can easily write. If it is 2 3 na 3 2, 2 5 means what? 5 2, 4 5 means 5 4, 4 7 means 7 4. Similarly, you can write the remaining element. This is R na, this is R inverse. Using this you can write. So using matrices, how to find? Matrix representing R inverse is same as MR transpose. This is MR transpose of this matrix. This is the 4 by 4 rows 3 column. This is what? 3 rows 4 column. So this is the first row, so this is the first column here. This is the second row, this is the second column. Third row, third column. Fourth row, fourth column. You can check it. So now this is actually what? 3 5 7. This is what? Here you should write what? 2 2 4. Here you should write 6 8. So this is what? 3 comma 2. This position is what? 3 comma 2 is here. Similarly, you can verify whether we are getting the correct matrix. So next concept is if the relation R from A to B, if R is what? Relation from A to B, and S is a relation from B to C, then composition. Okay, then composition of the relation R and S is defined by uh, R composition S, okay, is represented by the Boolean product of the matrices MR and MS. Okay, so I will tell you how to find the composition. So here this is MR, okay, this is MS. Now they are finding the matrix of R composition is matrix of R composition is. So actually, this is actually Veerarajan book. So in Veerarajan book, they are slightly different way they are doing. Okay, M R composition is equal to, first they will write what, MR, and then composition they will write what, MS. But this is this is they followed in what, Veerarajan. Veerarajan book. Okay, but for the same thing, MR composition is in Venkatraman book. They are following first. They will take MS composition MR. So Venkatraman, I am following both, but it is better to use Venkatraman book. Even if you use this one, you will get a mark, no problem. But entirely both of them are different. So why this difference comes? The reason is in the Venkatraman book they are using F composition G. Okay, means of X means first he is applying G, okay, and then applying F second. But in the Veerarajan book, F composition G, okay, is putting X here. First he is applying F and then he is applying what, G. So that's why. So because of this idea, so here what he is applying G first. So here in the MR composition S, he is first applying what? Here G means here he is applying what? S first. So that's why MS is coming first. Okay, composition and then MR next to F. Okay, F means what? Here instead of F, here what? R. So next R is coming. Okay, first S and then R. But here in Veerarajan book, first he is applying what? F. So instead of F, what do you have? R. That's why I'll write what? They write what? MR. Second, he is applying what? G. So instead of G, we have what? S. That's why MS is here. Okay. So this is I took a snapshot from Veerarajan book. As per Veerarajan book, okay, MR, this is MS means MR composition S. This means what? You should write MR composition MS. Okay. So now this is equal to, this look like just looks like a matrix multiplication. So take this row and take this column. Okay. So 0 and 0. Okay. First 0 and 0, you should write like this. 0 and 0 is what? 0. And then put R. Okay. Okay. Actually, instead of multiplication, you should use and. Instead of addition, you should use what? R. So 0 into 0. Usually, we'll put for matrix multiplication. So 0 into 0. Instead of 0 into 0, you'll put what? 0 and 0. 0 and 0 is what? 0. Next, plus we'll usually put. You put what? Instead of plus, you should put what? R. Next, 1 and 0. 1 and 0 is what? 0. And then instead of plus, R. And then 0 into 1. So 0 into 1, but 0 and 1 here. Because 0 and 1 is what? 0. Similarly, first row, second column. So 0 and 0 is what? 0. Next to R. 1 and 1 is what? 1. R. 0 and 1 is what? 0. And then first row, third column. 0 and 0 is 0. R. 1 and 1 is what? 1. R. 1 and 0 and 1 is what? 0. Similarly, you should write this matrix. So here if it is everything is 0, not 0. Here at least 1 now 1 because join. So here what? At least you have only 1. So if everything join means 1. Here also 1. Here also 1. Okay. Here also what? 1, 0, 1, 0. So this is the way you can find the matrix of what? The relation R composition S. Matrix representing the relation R composition S. I think I can stop here. Okay, the remaining problem we will discuss in the next class. I think up to this slide we discussed. Okay, slide number 5. The remaining thing we will discuss tomorrow. Okay, thank you.